Are we having fun yet? Okay, here we go. This time we're the Maclaurin series. So what does that tell you about A? A equals 0. Okay. For a function is given by this general term. Here are the first few terms already written out. And here's a term that's, dot, dot, dot later on that we might be able to use to help us. Converges to a function, to f of x for all x that is less than the radius of convergence, where blah, blah, blah. Use the ratio test to find r. I like it when they're nice and direct. Do this. So a to the n plus 1 all over a to the n. You should be pretty comfortable with these by now. So back up here to the top, this is my a to the n. So I'm going to write minus 3 to the n minus 1 plus 1, x to the n plus 1, divided by the original. Minus 3 to the n minus 1, x to the n. So I'm going to flip the guy and simplify. So n minus 1 plus 1 just leaves me with n. X to the n plus 1. Okay, yeah. Why did I do this? Maybe not. I'm going to simplify exponents and then I'll flip. Okay. Then minus 3 to the n minus 1, x to the n over n. So that might have been a redundant step, but yeah. Now I'll flip the guy. Minus 3 to the n, x to the n plus 1, all over n plus 1 times n.
Why is x to the n plus 1 there?
Because that's what it was here.
But why was that not there?
Because n, here's n. A sub n plus 1 is in the top.
Oh, it's
So that's n, and then over minus 3 to the n minus 1, x to the n. Yes. Okay. So let's do the easy stuff first. There's an x term that's left in the top. And then we've got an n and an n plus 1. So the part that's a little tricky are these exponents for this minus 3. And this is going to be so easy for you guys to mess this up. So if I take n minus n minus 1, this becomes n minus n plus 1. So if I subtract this exponent from this exponent, I am left with 1. So what I'm left with is minus 3 to the first power. So using what we talked about before, anything that's not involving n, we move to the front. So this becomes the absolute value of minus 3x, the limit as n goes to infinity of n over n plus 1. So after doing so many ratio tests, we know that this is 1. So we have to take the absolute value of minus 3x times 1 has got to be less than 1 for convergence. So I have to solve this inequality. So minus 1 less than minus 3x less than 1. What did I do? Okay, I'm going to multiply everything by negative 1 or divide by negative 1. Either way, all it's going to do is change the sign. And now I'm going to divide through by 3. 1/3 x minus 1/3. And I really should rewrite it so that the lowest term is on the left. So we rewrite it as minus 1/3 x less than 1/3. So that's my interval of convergence. The question is asking you for the radius of convergence, though. So you have to specifically write out that the radius of convergence is 1/3. Part B asks you, it says, write the first 4 non-zero terms of the Maclaurin series for f prime. This is f. They want f prime. They want 4 terms. How many terms did they give you? 3. So I actually have to figure out one more. So let's figure out the 4th term for our function. So this would be minus 3 to the 3rd, x to the 4th over 4. And if I simplify this, this would be minus 27 x to the 4th over 4. So we have to pretend that this term is right there. So when they ask you to take f, to find f prime, just differentiate the first 4 terms of this polynomial. This one is that easy. So this becomes f prime of x, use their notation, is 1 minus this times this exponent, subtract 1 is going to be minus 3x. This times this, subtract 1 from the exponent is going to be 9x. This times this, subtract 1 from the exponent is going to be minus 27x cubed. That one squared. Now, this question goes on to say, express f prime as a rational function. Okay, that's a little scary. So what they're asking you to do is to notice that if you study these terms, if you compare this term to this term, this term to this term, this term to this term, do you notice anything? What do you notice? Multiplied by, which makes it, starts with a G. Geometric. So this is a geometric series. This is geometric. R is equal to minus 3. And to find a function, we use that sum of the series equations. A1 over 1 minus R. That's all they're asking you to do. So all you got to do is say the first term 1 over 1 minus negative 3x. This is all they're asking for. Done. The last question is very common on this exam. If you get a question for the power series, they always like to have you dream up these other power series that, so in other words, they take what you have and they want you to multiply it by something. So it says, write the first 4 non-zero terms of the Maclaurin series for e to the x. All right. So e to the x is, does anybody know?
E to the x.
What are the first 4 terms?
X is x.
No.
1 plus x plus x squared over 2 factorial plus x.
Yes, and you have to be able to do that. So it says, right? So you'll probably get a point for that. Then it says, use the Maclaurin series for e to the x to write the 3rd degree Taylor polynomial for g of x. G of x is made up from e to the x times f of x, about x equals 0. So this is going to turn into a big algebra problem. So g of x, they want you to take this 1 plus x plus, and I'm going to simplify, x over 2 plus x squared over 2 plus x cubed over 6. And then they want you to multiply it by f of x. So I'm going to take the first few terms of this one. X minus 3/2 x squared plus 3 times x cubed. They want the 3rd degree. So that means we need an x cubed term. So that means we have to start multiplying this crap together. I don't have to ever go out to the x to the fourth term. So I'm going to say, do the 1. X minus 3/2 x squared plus 3x cubed. So I'm done with that one. I take this one. X times x gives me a plus x squared. This times this one gives me minus 3/2 x cubed. I don't need to go to x to the fourth, so I can stop with this one. Now I take this one and multiply it here, and I